So online student, can you hear me? वो ऑन है क्या? देखो जरा इसका switch. Okay. So starting now, the next topic is logic gates. Okay, how to implement logic gates using transistors. Okay. So the first gate you see AND gate. So if I connect transistor in this manner in series, okay, ammeter is connected to the collector, and here you have a power supply, and I'm taking the output in this position. Okay, now if I say my A is 0, okay, say my A is 0, how to take the this one? This one. Okay. So say if A is 0, okay. Use fingers. Then. Okay. So if I say my A is 0, okay, and B is 0, tell me what will happen if A is 0, B is 0? Bases are, base will be reverse bias. IB will not flow. Okay. If IB is this, IB is not flowing, this IB is not flowing. Okay. So here IC is not flowing. Okay. So output will be here no current, no IE is coming. If IB is 0, obviously IE is 0. This IB is 0, this IC is 0. If this IB 0, IB 0, this IB 0. Okay, automatically this IB 0, this IC 0. Okay, and this IC 0, this IB 0, this IE also 0. So here I get the 0 voltage. Okay. Now इसमें back कैसे जाएंगे? Undo. Eraser कहाँ है? Okay. Now you see that neck. कहाँ पे? Undo. Yes. Okay, yes, okay. Jaidev. Okay. इसमें कंप्यूटेबल नहीं है, फास्ट नहीं है इसके अंदर, बहुत स्लो है. Okay. So now this is if is B is 1. Okay, B is high. 1 means B is high. So obviously if B is high, okay, and A is 0. So if A is 0, automatically this current is not flowing. If A is 0, this I is not flowing, and now but this current is 0. This current is flowing, okay, but obviously IC is not flowing, so automatically again this IC, this current is also 0. So your output will come again 0. Okay, ये clear है point? Okay, similarly कोई भी एक भी 0 है इसके अंदर, your output will come 0. If both are on, if both are high, then this is high, IB will flow, IC will flow, here IE will flow. If IE flowing, this IB flowing, automatically some current will flow here, so you'll get high output here. So when transistors are connected in this manner, you can say this is they are implementing AND gate. Okay, तो सर्किट बना लो बस इसका AND gate and table बना लो.
स्लाइड से करते हैं ना.
हाँ, ओके, स्लाइड से कर देंगे. भी अगर थर्ड केस में A is 1, so obviously this current is flowing, this current is flowing, IC is flowing, but IB is not flowing. So IB ये सब flow करना चाहिए. Okay, this cannot happen that this is not flowing but this is flowing. This cannot happen. Okay, so finally it's become 0. फुल स्क्रीन कैसे करेंगे इसमें? A5 चलो ऐसे दिख रहा है ना इसमें, ऐसे देखो. दिस इज फुल स्लाइड. ओके,
Sir, play में ही हो. First page of first page, हाँ, first.
ओके. नाउ
Sir, इसमें तो minority charge है कि
IB तो डिफ्यूजन करंट है. PN जंक्शन में whenever you do PN function, forward bias, majority charge carried flows. Majority charge IB तो PN जंक्शन में करंट फ्लो हो रहा है ना, that is diffusion current ना. Diffusion current is always majority charge carrier. Okay, so next is your OR gate. Okay, now tell me what will happen now. Here what now this VCC is directly connected to this load. Okay, no, this VCC is directly connected to collector. Here connected to this collector and this is connected to this collector and this current is flowing here. Now tell me what will happen if both are 0, this is 0, this is 0. Okay, then current cannot flow, IC cannot flow, you get 0. Okay, now any1 is high. Suppose now this transistor does not depend on IC. This is directly connected to this high voltage. Okay, now suppose this is conducting, this is 1, this is 0, this is 1, this is 0. Then also current will flow, and whenever current will flow, the output will become high. Are you getting? If both are 0, then there is no current in the load. But if both anyone is conducting, so obviously now this voltage is directly coming here, IC will flow, IB will flow, some current will flow here. So if any one of is 1, the output is 1. When both are 0, then only it is 0. So this is implementing your OR gate. Okay.
Sir, can you explain how it works?
So now say here, this is directly connected this one. If and suppose this is 1, this is 0, this is 0. So IB is 0, IB1 is 0, IB2 is 0, IC1 is 0, IC2 is 0. Obviously this IE is 0. No current is here. No current here. Okay. Now say this become 1. Say this become 1. So it is connected to high voltage. Okay, IC can flow, IB can flow, IE1 can flow, and this IE1 can come here, IE1, and you get high voltage here. Okay, similarly, if this is 1, this is 0, then also current IE2 can come and you can get voltage here. If both are connected, then both current can come here and you can get the high voltage.
Sir, in this case, we get different voltages out case, right?
Yeah. If these resistance are same, voltage is same, this power supply is same, then you get the same here, but both are 1 1 1. Then you get double current. But this is a high voltage. Okay.
So the doctor it is not zero because
Pardon?
it is that not a particular part that is if the voltage is not zero, it is considered to be
क्या question?
सर एक अगर जीरो नहीं है
हाँ.
तो it is
Yeah. If anyone is high, this is high. Okay. Any out of two, anyone is high, this will be high. Okay. Now instead of the same AND gate circuit, in the AND gate circuit, what I'm doing, I was taking the output here down. Now I'm taking output here. Okay. Now if I say my A is 0, A is 0, B is 0. If both are 0, then what will happen? If this is 0, IC will not flow. This IC will not flow. IC will be 0. And if IC is 0, no drop is there, this 6 volt will come here. Okay. If this is 0, now this current is IC. This becomes 0. So this voltage will directly come here. Okay. Now we say this is 0, this is 1. Same thing. If this is 0, this current cannot flow. This will come 0. Again 6 volt, 1. But now what happens if this is 1? If this is 1 and this is 0, तब क्या होगा बताओ? Then this is 1, IB flow, IC flow, this flow. But here because this is 0, this cannot flow. IC2 is 0. Okay. So then also current cannot flow. This current cannot flow, then this current also cannot flow. So again you have 1 and both are 1 1. Then current will flow. If both are 1 1, then current will flow. If current flows, all the drop will come here. And here voltage will be low. If current flows, then there will be drop. If current is not flowing, there is no drop. This point is directly coming here. Huh? Down मतलब? If current flow कर रहा है, then there is a drop. The 6 and this all voltage will drop here. Okay, correct. If current is not there, this is 0 drop and this point will directly come here. 1 1 वाले में तो करंट फ्लो कर रहा है, तो इस करंट फ्लो कर ही नहीं रहा है. In the only 1 1 case, this circuit is complete. This is conducting, and you are getting here. Any other case, suppose 1 0 1 0, because this is not conducting, obviously this will not conduct. So these two can conduct simultaneously. Okay, because now VCC is not connected directly, na? If this is conducting, then only this will conduct. Okay, this conducting, this will conduct. So they are like an AND gate. Okay. So now if it is 1 1, then 0. All other cases is output is 1.
1 1 वाला मतलब अगर वो ड्रॉप भी हो रहा है.
हाँ नहीं कुछ भी नहीं आएगा. कुछ आएगा ना. जैसे 6 आया, तो ये वोल्टेज कहाँ ड्रॉप हुआ? यहाँ ड्रॉप हो गया. तो यहाँ पे क्या आएगा? यहाँ पे लो वोल्टेज आएगा ना. लो वोल्टेज आएगा. हाँ, इसके कंपेयर जीरो मान लो, because there is nothing. If I assume this VC everything 0 0, okay, because now listen, why VC is 0? Tell me. There is no drop on VC here.
VC0
here VCT there is no drop because this is working as a saturation mode, because you are applying B very high. Actually what happens, you require VB only 0.7 volt, but now this A base voltage is very high. So whenever base voltage will be very high, IB will become very high. When IB will become very high, IC will become very high. So IC become high means it is going to the saturation. If you see the curve like this is your curve. This is IC and this is VC. Okay, now if you're going higher and higher IC, okay, then VC is getting keep on dropping. So here voltage is very high. It's a 5 volt is very high voltage for base. Okay, so this will bring this transistor working in the saturation region. So here VC in VC there will be no drop. So all the drop will come here. That's why I say this is 0. Okay. बनाना है तो कैसे करें बनाने के लिए अंडू वो ट्रांजिस्टर का नाम है ट्रांजिस्टर जैसे कोई भी कंपनी बनाती है हाँ अब इसका मुझे ध्यान नहीं है कल बताता हूँ देख के ठीक है ट्रांजिस्टर का क्या होता है तो नेक्स्ट स्लाइड okay now this is the same like a OR gate में we were taking the output down I will take output up exactly OR gate that means VCC is connected to the both collectors okay now tell me what will happen if 0 0 0 if this is 0 this is 0 so if this is 0 this current cannot flow okay this current cannot flow and this is also 0 so this current cannot flow here also so output will come high okay so low if you have low okay then this will be your high because no current so this will be 0 okay now if 0 1 this is 0 and this is 1 then which transistor will conduct which transistor will conduct ये वाला connect कर जाएगा if this is 0 this is not conducting so this path is not available this path is not available but this path is available okay so current will flow so all the here there is a no drop okay I'm coming from here and then I'm coming here down directly okay because this path is conducting in this path there is a VC 0 and with all voltage getting drop here this will be a 0 okay second case similarly 1 0 also this 1 will conduct so current will flow from here okay through this transistor to here so again the output will be 0 okay and both are conducting then also you can take this path or you can take this path okay the big output is 0 when both are not conducting okay then only current is 0 and you get a high output here so this is your NOR gate opposite of OR gate oh yeah अभी क्वेश्चन सारे TFI में पूछे हैं they made a circuit and they said identify the logic gates Okay. So next is your now NOR gate you can implement with this with
सर नॉट वाले के लिए एक ही ट्रांजिस्टर लेना है और ऊपर से लाइक कलेक्टर से आउटपुट ले लें तो नॉट के काम करें।
कौन एक ही
हाँ
तो एक में फिर ये गेट कैसे वेरीफाई करोगे?
ये नॉट
नॉट में एक में हो जाएगा, नॉट एक में हो जाएगा।
आउटपुट कलेक्टर से ले
हाँ नॉट में बनाया नहीं क्या? नॉट में तो हो जाएगा, यू टेक ओनली वन दिस वन, इफ दिस इज ऑन then this is off, this is 0, if this is 0 this is 1. Okay, NOR gate में क्या हो जाएगा? NOT gate, simple NOT gate, you have this transistor like this, okay, and this is your plus VCC, okay, and you say put a resistance or put directly. If this is high, okay, obviously this point will be low, because if it is flowing this will flow, so drop here, drop will be 0, because if this is VC is 0, VC is 0, this is 0, if it is high. Similarly, if this is low, okay, then current will not flow, so this is VCC will come directly here. So this is the NOT gate, this is your NOT gate. Single transistor is a working like this is a NOT gate, very important है, ये बहुत काम आएगा। अभी हमने क्या कट ऑफ में किया था ना, कट ऑफ when we are doing transistor cut off region, so if this is 0 that is high. Last year class gate question. So here, tell me what will happen here. Here, if is both are 0, 0, then current will not flow. Okay, if this is 0, this current cannot flow. If this is 0, this current cannot flow from here. So here, this will be high. ये हो गया ना? Same, but इसमें circuit is little bit different ना? No, हो गया. And this is one more circuit for NOR gate. Now what is happening here? Tell me, बताओ क्या होगा यहाँ पर? If it is high, then what will happen? अब बताओ, अभी तुमने समझ लिया है, अपने आप फटाफट बताओ. If A is high, then what will happen? Base will saturate. This will saturate. Current will flow. If base is high, current will flow. If current is flow, output is 0. Okay, if anyone is high, output is 0. If both are not connected, then only output is high. So this is your NOR gate. ये जो देख के पता चल जाएगा फटाफट से.
अगर ये दोनों सीरीज में लगाते हैं तो एंड गेट और नैंड गेट जैसे काम करेगा?
दो डायोड लगाते तो
नहीं, ए बी को हम सीरीज में लगाते हैं, सॉरी ए बी नहीं, वो जो 10 डॉट पर 10 किया था इसे हम सीरीज में लगा के और आउटपुट वहीं से है ना,
वो करके देखना पड़ेगा, बहुत तरह से बनता है. इज नॉट ओनली सिंगल सर्किट, दिस इज आइडिया यू हैव टू आइडेंटिफाई.
तो नैंड जैसे ही काम करेगा.
So now this is a NOR gate. Next is, बताओ ये कौन सा गेट है? अभी मैंने टेबल बनाया नहीं मैंने तुम्हारे लिए. बनाओ. Put measure truth table, give the value A and B high and tell me ये कौन सा गेट है? So make the table. Say A, B, and then you have B naught. Okay, so this is 0, 0, 0, 1, 1, 0, and then 1. NAND बताओ तुम क्या NAND है कि NOR है क्या है? अब ये तो सिंपल बता रहा हूँ मैं ए बी you can write any Boolean expression using these gates. Suppose I want to write a plus bc, that also can be implemented like this. NOR. बताओ क्या होगा, बताओ. Tell me what will happen if both are high, then what will happen? If both are, if this is low, say this is low and this is also low, then this diode is forward bias or reverse bias? ये हाई वोल्टेज आ रहा है यहाँ पे, this high voltage coming, so through this path this diode will conduct. This is short circuit and this will conduct, and this is 0, that means this is the ground. Okay, both will conduct. This is also conduct. This is a ground. If this is a ground voltage coming where? This is ground. This ground voltage coming here. This voltage becomes 0. This voltage becomes 0. This base becomes reverse bias, cutoff region, cutoff. This current cannot flow. So this voltage high will come automatically here. Okay. So this, when both are 0, 0, you have output is VCC, high voltage. अब बाकी सेकंड देखो, सेकंड चेक करो क्या होगा. Tell me. Yes, ideal. Diode is ideal. Diodes are ideal. Tell me. Now next what will happen? Tell me. 0, 1. So if any diode is conducting, then what will happen? Automatically this point will become 0. इनमें से कोई भी अगर diode ground हो जाएगा, suppose this is ground or this is ground. If both can be ground, if suppose this is ground this time, this is conducting, then this ground will directly come to here, and this will be cut off.
But when both of them were right, that also will be
Yeah. Right. This is ground or this is cut off. This is high voltage. Okay. Now, if anyone is conducting 0, 1, then this will become what? This becomes 0. This is still not conducting. Still not conducting means this is still plus VCC. Okay. 1, 0 also plus VCC. If no, how 1, 1 में क्या होगा? 1, 1. Now this is a high voltage. This is high voltage. So this is high. This is also VCC or more than that one. So this will become open now. If this is high, so this will become open.
So that is take the B base connected to the ground.
So, no. Where is now? Once it is open, there is no path. No current is not going here. No path. So this current now get activated.
No, there is another part.
Which one?
This like that continuing from R to the
Where is the ground? This ground.
something.
This ground. if voltage is coming here, okay, yeah, no, this line should not be there. This huh? इस लाइन के ऊपर नहीं, उससे मतलब नहीं है, वो तो एक ही बात है. Yes, wait. So if these are not coming, then this will not this will be ground. Okay, this ground should not be there. This line should not be here. This should not be here. This should be directly like this here. This line should not be there. Okay, this line should not be there. So you cut it this one. So this is basically what is making, we are making NAND gate, na. So this is what we have seen earlier. Earlier we have made the AND gate. AND gate is just this one. AND gate is, last class we have seen that before when we are doing diode. I say this is my AND gate circuit. So when AND gate output is 1, okay, this will become saturation. You'll get 0 here. And when AND gate output is 0, AND gate output will take here. Generally, we take output here. When this is 0, automatically this become your cutoff. So this line is not there. So this is 1 will make this are conducting. So this will be, your output will come 0. अब NAND gate ये रहा. Next is this one. Here also maybe some mistake. Now check this one. What will happen here? If this is 0, then measure table. Last one was NAND gate. Check this is whether NOR gate or some other gate. Now this is your A. This is your B. And this is your V naught. Tell me क्या होगा? If both are 0, नहीं लगा अभी नहीं लगा हुआ. If both are 0, then what will happen? If this is 0, this is 0, these are open. There is no voltage here. If no voltage here, that means what will happen? This current is not there. So VCC will come at the V naught. So 0, 0, you got plus VCC. Actually, maybe this is circuit you were looking for earlier. Now tell me next 0, 1. So this is 0, this is 1. So here will come high voltage. Here will come high voltage. Okay. So this will become 0. Similarly, if you have 1, 0, then also 0. And both are 1, 1, then also 0. So ये कौन सा गेट है? NOR गेट है. It's NOR gate. एक्सप्लेन करना है इसको दोबारा. If both are low, then these diodes are open. These diodes are open. Okay. And no current is flowing here. This point is grounded now because no current is flowing. This point is grounded now. When this is grounded, this is in cutoff region. Cutoff region means IC is not flowing, and cutoff region means directly this will come here. And when this is a high, very high, okay. So any one of is high, this point will become high because this becomes short circuit. So if this high, whenever this becomes high, very high, then this transistor goes in saturation, very high current flows. So voltage comes here 0. Okay. So cutoff में पूरा voltage आएगा and saturation में क्या आएगा? आपका जीरो आउटपुट आएगा, अगर आउटपुट इस तरह से ले रहे हैं तो दैट, ये तो इतना याद रखना है बस। ओके, तो नेक्स्ट है ही नहीं। ओके, सुनाओ, कट करना है इसको। ओके, अब लास्ट टॉपिक इज ट्रांजिस्टर। आज करना है कल करना है? तो आज फिर प्रॉब्लम्स करो प्रीवियस ईयर्स का। ओके ओके,
प्रॉब्लम ही करते हैं। इतना सारा पढ़ के फिर याद नहीं रहता।
सो लेट अस डू प्रॉब्लम्स। So I will share the previous year questions. Okay, start doing now. Now see the question number 1. Okay, for unbiased NPN transistor. Okay, you have NPN transistor which is in equilibrium, which is unbiased. Okay, tell me the Venn diagram of this one. Which is the option? कौन सा है? B. Okay, why? Because when we draw PN junction I have drawn like this. This is my PN. So NPN will be like this. This is option B. Okay. Now see the next question. Next question says to operate an NPN transistor in active region, is emitter base and collector base junction respectively should be. Emitter base junction क्या होना चाहिए? And collector base junction reverse bias. So option A. Okay.
क्वेश्चन
हाँ,
जो डोपिंग लेवल है एक साइड के और दूसरे साइड के डोपिंग लेवल
नहीं, वो अभी ऐसे बोला नहीं ना, बोलेगा तो हो सकता है, बट डायग्राम ऐसे ही बनेगा, थोड़ा सा ऊपर नीचे हो सकता है, क्योंकि अगर फर्मी लेवल डोपिंग अलग अलग है तो फर्मी लेवल शुड भी अलग अलग होगा। अभी तो सेम ही बताया है। Now for using it transistor as an amplifier, choose the correct option regarding the resistance of the base emitter and base collector junction.
low
So base emitter is the input, so it should be low, and base collector is output, it should be high. तो कौन सा ऑप्शन है? क्वेश्चन नंबर 3. वेरी लो बी इन, वेरी हाई डीसी। ये होता है एम्पलीफायर के लिए, इनपुट शुड बी लो रेजिस्टेंस, आउटपुट शुड बी हाई रेजिस्टेंस। नाउ द क्वेश्चन नंबर 4, in the given circuit VCC given 100 volts and beta is 100 NPN transistor, the collector voltage VC in volts is, okay,
equal to 0.7
निकालो। So this is your circuit. Plus VCC, VCC कितना दे रखा है? 10 वोल्ट। This is 100 kilo ohm resistance here. This is a 5 volt. And this is the ground. 1K. So you want to find the collector voltage VC. Collector voltage VC is this one, which is equal to. So first find the IB. Beta is 100. So IB कितना आएगा? IB will be 5 minus 0.7 divided by 100K. So 4.3, that is 43 microampere. 4.3 and 10 raised to power 5. And IC will be 4.3, beta is 100, 4.3 milliamperes. So VC कितना हो जाएगा? VC will be your VCC minus ICRC, because VE is 0. VC minus VE. VE is 0, so VC is basically equal to your VC. So this is 10 minus 4.3, RC is 1. This will count 5.7 volt. Next question. Collector voltage with respect to the ground. Okay, BB is given 0.7 and they say beta DC is very large. Beta is very large. Beta is very large. So question number next. Beta value is not given. See, beta is very large. Okay. So this is your transistor minus 3 volt. थ्री के प्लस 10 वोल्ट. ओके, बताओ क्या होगा? So this is forward bias or reverse bias? Ammeter base junction. Because यहाँ माइनस लगा हुआ है ना आपकी. Okay, so say this is VBE 0.7. So what is the answer? I'll start. This is 0. 0 means what? Minus. Okay, this is 0. So current. So I'm assuming the current is flowing. This is the current flowing like this. So I'll go in the direction of current. So this is current flowing. That means, tell me, this is a plus, this is a minus. Okay, so I'll add IB into RB. This is RB, 3 kilo ohm. Okay, 3 kilo ohm plus 0.7. And this value is how much? 1K. 1K is IE. So IE into 1000 ohm. Okay, and then minus 3 equals to 0. And IE I can write what? IE I can write beta plus 1 IB. So beta is not given, na?
Approximation.
Huh? Approximate how can I take? Beta is very large in this question. So how can, so question में क्या पूछा है? VC पूछा है. They asked what is the VCE?
तो VC पूछा है, VC only.
Okay. VC पूछा है, then tell me what is the voltage? How can we find the voltage here? -3 plus this one plus this one. Just 1 minute. नहीं ऐसा कैसे करेंगे? For the circuit ITJM, just 1 minute. इसमें क्या दे दिया उन्होंने?
When we find the IC, there will be a beta plus 4 in the numerator and 1 beta plus 3 in the numerator and beta plus 1 in 4 in the denominator. And this is so high.
Okay. So if you say beta is very high, how can I write now? Tell me. I can write IB equals to, tell me what I can write now. IB minus 3 minus 0.7. Okay. This is 3 into 10 raised to power 3, and if I say this is I is equal to beta plus 1 into 10 raised to power 3, correct? Beta plus IB is coming here. Now if they say beta is very high, beta is very high, so IB you can take 0 now. IB almost 0. If IB is 0, IC is 0. Okay, so this VC will become now 10, and this is also 0. So this point will become now -3 volt, and this become 10 volt. So answer VC should be 13 volt. Let me check answer. VC पूछा है. Compare to ना क्या पूछा? Collector voltage with respect to ground. So with respect to ground यहाँ पे है कहाँ? तो ऐसे थोड़ी दिखा. You can find this with respect to this. Do directly you cannot find. This is VCE. Okay. Let me check the answer. 1, 2, 7. VC with respect to the ground. So 1 minute, I'm saying the solutions also. क्वेश्चन नंबर क्या था ये? 5 में दे रखा है 3.1 वोल्ट. So how do you do for the input? They also taken IB 0. So if they take IB 0, how can they take IB 0 here? Then I coming 2.3 milliampere.
But it's not that we are taking 90. It's 2.3 milliampere. We cancel out
What are you saying? IB?
IB is equal to beta. Right?
Yes.
So there will be beta plus 1 in the denominator, 1 beta.
Okay. So what they're doing question? Okay, we are taking IB negligible. So if I take IB negligible directly, I can find IE from here. Okay, so tell me now what will be the IE value? IE value 3 minus 2.7, and this is you should not write this one. IE into RE 1 kilo ohm 2.7. Okay, this is 1 kilo ohm. So this is 2.7 milliampere. Now 2.3 milliampere. Okay. Now what is the voltage? Tell me here. If 2.3 milliampere flowing here, what is the voltage here? Now this will be IE. This will be IE. Okay. So IE equal to IC. Okay. Tell me now what is the voltage VC? How much? VC how much? Now you write the loop equation here and tell me what is the value. VC is 3.1 volt. So VC will be your VC will be VCC minus ICRC. VCC is your 10 volt, IC is your 2.3 milliampere, and this is your 3 kilo ohm. So this will come 3.1 volt. Okay. Wait, next question. हाँ, तो इसमें क्या किया है? If I write the equation here, so if I want to write the equation, how would I write the equation? Obviously, current will flow like this. So I'll write IB into 3 kilo ohm plus VB is 0.7, and then plus IE into RE, which is 1 kilo ohm, and minus 3 equals to 0. Okay. अब ये क्वेश्चन में बोल रहा है कि because beta is very large, okay, so I can say this is negligible. IB is negligible. So compared to this part, I can neglect this IB because IB is in microampere. IB is in microampere, so I can simply say this my 0.7 into IE, okay, and this term is equal to कौन सा वाला? हाँ, 0.7 plus IE into this current. This part is equal to 3. This part is equal to 3. This is negligible. This part IB is 0. So my equation is only this much. And by solving this one, we can get this one. So IB is not 0. We are putting negligible. Okay. Because IB if is 0, then nothing will flow. IB is negligible. Okay, good. Next question. Question number 6. Now this asking the value of RB. This question they have given you VCE. So this is the fixed bias circuit. Okay. This is your one kilo ohm, and then you have a 2 kilo ohm. This is RB equals to 0. Okay, 20 volt. So last question, what we've done, okay, I'll check his answer first. Okay, original answer sheet, I'll check the answer, then we'll discuss. For the mean, I have given the answer this much. Okay, I'll check the real answer book key, and then I'll see what is actually. Because when I was doing, we should put IB 0 only.
नहीं तो हम उसमें ऐसे भी तो करते हैं जब हम आईसी दे रहे हैं बीटा ई ठीक है देन बीटा ई और नीचे अपॉन में 3 प्लस बीटा प्लस 1 बनता है तो वो बीटा हमारा बहुत ज्यादा हाई है तो हम डायरेक्टली कैंसिल आउट कर सकते हैं ये हमारा 2.3 into 10 raised to the power minus 3 the 2.3 micro milliamp to I directly आई से हमारा देन आई से
हाँ कैसे
तो हमारा बीटा ई भी होता है ना तो यहाँ बीटा लिखा आई भी हमारा यहाँ से आया
हाँ वेरी गुड हाँ कैंसिल हो गया
तो ये बहुत ज्यादा हाई है तो +4 करें तो भी
नहीं तो बीटा प्लस सब कैंसिल हो जाएगा करेक्ट हाँ ये करेक्ट आंसर है करेक्ट
उसको ले रहे इसको हम यहाँ यूज करें
yes that is correct. Okay, so the last question, we should not put the 0. Okay, directly he is saying this is good method. You can get here IB value, okay, So what is the IB value? Tell me. IB value 3 minus 7 and then 3 and then plus beta plus 1 into
1 into 10 raised to the power.
it is correct.
Yes.
Okay, now you want IC, so IC will be your beta IB. You're telling like that, na?
Yes.
So then,
हम वहाँ पर
so beta is very high. Beta is very high. Okay, so now beta is high, so I can neglect this part. See, this is kilom, and this is beta plus 1. This is 3. So this is very large. So I can write this is a beta. Okay, multiply IB is this is 2.3, and this is your beta plus 1 3. Now this beta is very high. I can neglect 1. I can cancel this one. Okay, and this will become 2.3 milliampere. And this you can use later. तो ये सही है ज़्यादा तरीके से. हाँ, तब भी यही कहता, तब हमने इसको यहाँ वो एक्चुअली क्लियरिटी नहीं आ रही ना, तब वो क्लियर उससे क्लियरिटी हम वी आर मेकिंग 0, उससे क्लियरिटी नहीं आ रही ना, बट इससे क्लियरिटी आ रही है ना हमको कि वी आर नॉट मेकिंग बिकॉज इफ यू से IB is 0 then everything is 0, then this 10 volt should come here. IB is not 0, so this is the logic. तो जब भी आंसर भी बढ़ाना है तो लॉजिक तो सही होना चाहिए. ठीक है, वो पहले का पता नहीं कहाँ लिखा हुआ है कुछ. नेक्स्ट क्वेश्चन, टेल मी क्या आएगा. द VC इज गिवन हाउ मच वोल्ट? 14 volt. VC is given 14 volt.
Approx 865.
VB is given 0 point. ओके, बताओ सबका RB कितना आ रहा है? 8 point something आएगा. So here current IB is coming here. So minus 20 plus IB into RB plus VB. Okay, then plus beta plus 1 RE equals to 0. Now tell me how to do. BC is given और क्या दे रखा है? IC is equal to RE. तो कैसे करेंगे बताओ? VC is 14 volt. So can we find here IE from directly from here in this equation? कैसे? IB को रख दो minus 20. IB is what? IE upon beta plus 1 into RB plus VB plus beta plus 1 RE IE equals to 0. अब tell me.
Why we need a beta plus 1 beta plus 9?
No, but what is the advantage? I'm asking how to do solve this problem. See,
In the equation, YP is at theta plus 1. We are directly between I and R, right?
this IB I want to change. I want to convert in the IE form.
Sir, one of
Then where should be theta
Huh?
not in the second.
Which one? Beta 1 plus
IERE लिखा है, IE लिखा है,
IRB IB लिखना है. Okay, so this is everything IB come na, but IB how can we find IB if is RB is not given? बताओ कैसे करेंगे इसको?
We are given the basic, right? And
So you have VC, you have given VCE VCC minus IC RC. Okay, VC is given, correct? VC is given your 14, VCC is your 20. You can find IC directly from here. Okay, so not what to write. So your IC will be IC into RC will be
IERE आएगा,
हाँ?
plus IERE.
IC RC और ये भी आएगा RC plus RE, correct? Okay, so now tell me what is the value of IC? So IC value will be your 20 minus 14 upon RC value is 2 kilo ohm and this is the 1 kilo ohm. This becomes 6 upon 3 kilo ohm, 2 milliampere IC coming. So automatically you can find. क्वेश्चन में पूछा क्या है, क्या निकालना है? RB निकालना है.
निकल गया, तो यहाँ पे के लिए
So IC से you can directly find IB. So IB will be your IC upon beta
20 माइक्रो.
20 microampere हो जाएगा. अब इसमें we would put RB, you can find the RB value. Okay. नेक्स्ट क्वेश्चन में क्या करना बताओ? ये क्लियर है सबको क्वेश्चन? सो यू नाउ है आंसर 8 पॉइंट समथिंग आएगा. तुम्हारा कितना आ रहा है? Answer is 865 ohm. 865 ohm. Kilo ohm आ जाएगा. 0.8 kilo ohm. So the answer is RB is equal to 865 ohm. कुछ और भी आ सकता है approximately चेक करो. इसकी की पे भरोसा नहीं है.
सर 865 ओम्स है, तो किलो ओम्स में उसने यूनिट दे रखा है, तो 865 आ रहा है, तो 865 किलो ओम्स होगा ना.
अच्छा 85 kilo ohm. Put the next question. Question. अब कोई अच्छा क्वेश्चन करो, सब सेम क्वेश्चन लग रहा है. Which is the good question?
9.
9 करो. Solve the question number 9. अच्छा. So this is say this one 4 kilo ohm and VCC is your 10 volt. This is 2 mega ohm. And this is your 2 kilo ohm. Okay, and here you have a bypass capacitor. क्या पूछा है क्वेश्चन में? The value of ammeter current in the given circuit round microampere rounded to 1 decimal place. निकालो ammeter current. It's simple question here coming. So here minus 10 plus IB, RB plus VB. Then for DC, this will be open, capacitor will be open. So again, beta plus 1 IB into 2 kilo ohm equals to 0. Okay. So your IB will be, tell me, क्या आएगा? 10 minus 0.7, RB is 2 mega ohm. बीटा कितना दे रखा है क्वेश्चन? कहाँ पे? 0.3. And what is the value of beta? 100. So this is 101 into 2 into 10 raised to power 3. So this is 0.9.7. ये कितना हो गया? 100 and this one कितना आएगा? 2 point something. 10 raised to power 5. So 0.2 mega ohm. Okay, so around 2.2 something, 2.2 mega ohm.
ये आ रहा है सर 4.409 माइक्रो.
So 4.409 microampere multiplied by 100. IC will be beta plus 1 or IC will be beta plus 1. Beta क्या है आपका? 101 into 4.409 microampere कितना आएगा?
445.
445. ठीक है, ऑलमोस्ट ये है. So 445 कर दो, 445.1 कर दो. आंसर में देखा 444.9. तुम्हारा 445 आ रहा है.
4.4.
ओके, ठीक है. अब क्वेश्चन नंबर 7 करो. 7 करोगे, 8 करोगे? क्वेश्चन नंबर 8.
8 करें.
क्वेश्चन नंबर 8 करो. An NPN transistor is connected in a circuit as shown in the figure. If the IC equal to 1 milliampere, beta 50, VB 0.7, and the current through R2 is 10 IB, where IB is the base current, then the ratio of R1 by R2 is. ये तो क्वेश्चन हमने पहले किया है क्या? Okay, so this is 6 volt and voltage divider circuit, R1, R2, .5 kilo ohm, 6 volt, and this is your 2.5 kilo ohm. This is your VC and this is your VE. VC and VE both are given. VC is given 3 volt. Okay, 3 volt, and VE is given 0.5 volt. Okay. So you can find directly, you can find IE here because VE is given, so IE will be your VE upon RE 0.5 volt and 0.5 kilo ohm, so 1 milliamps. Okay, now tell me what is the value. So I is equal to IC हो गया 1 milliampere हो गया directly. Okay. Now you can find what is VC. VC is your VCC minus IC RC. 6 minus 1 milliamp into 2.5 kilo ohm. Okay, so this become how much? 6 minus 2.5, 3.5 volt. Okay, obviously this is 0.5, so this is difference. This is 3.5 volt VC. क्वेश्चन में पूछा क्या है? निकालो, कैसे निकालोगे? So you find the voltage VB here. Now you know this one. See V is 0.5, so VB will be how much? 1.2. If V is your 0.5, this is 0.7. VB is basically what? VB is your VBE plus VE. So this will be 0.7 plus V 0.5. This is 1.2 volt. Okay, and if I say IB is approximate method, IB is negligible, then I can write my VB is equal to 6 upon R1 plus R2 into R2. Okay, now 6 into R2, R1 plus R2, VB is my 1.2 volt. The same question we have done. 1.2 R1 plus 1.2 R2 equal to 6 R2. Okay, so 1.2 R1 equal to 4.8 R2. So R1 by R2 is your 4 and R2 by R1 is your 0.25. ऑप्शन में क्या दे रखा है?
पहले क्वेश्चन गलत है।
हाँ, क्वेश्चन में मिस्टेक हो सकता
थोड़ा
है।
सा इंग्लिश में।
इसमें वो उल्टा दे रखा होगा। क्वेश्चन 8 क्वेश्चन नंबर, सो R2 बाय R1 आएगा आपका 0.25। क्वेश्चन नंबर 11, क्वेश्चन नंबर 11 एंड 12 आज ही कराया है। 11 तो 12 तो आज ही कराया है। पहले अभी यहाँ कर लो 11 12। 11 एंड 12, क्वेश्चन नंबर 11 एंड 12।
कुछ बीटा यार होगा बीटा प्लस 2
देखो उसमें जा पड़ी सब क्वेश्चन देखने पड़ेंगे। मैं तुम्हारे साथ फर्स्ट टाइम ही देख रहा हूँ। क्वेश्चन नंबर 12। हाँ, 12 तो आसान ही है, अभी भी कराया ही है। क्या पूछा है इसमें क्वेश्चन में? व्हाट इज द वैल्यू ऑफ आई नॉट, जैसे IC पूछा है।
बीटा यार होगा
सो 30 माइनस 0.7 डिवाइड बाय 5 किलो ओम। सो क्वेश्चन नंबर 11 पहले कर लेते हैं। क्वेश्चन नंबर 11 यू हैव, दिस इज $100 kilo ohm, 900 ohm, and then you have a 15 volt, and this is your 100 ohms. बताओ कौन सा ऑप्शन सही है? Consider the following circuit in which the current gain beta DC is the 100, beta value is 100. So operating point बताओ, beta value is 100. तो पहले तो एंड पॉइंट बताओ, IC वर्सेस VC. हाँ, तो VC will be your 15 volt such when your IC 0 कट ऑफ में and this
सैचुरेशन हो जाएगा 15 मिली एम्प्स VCC अपन RC में था
VC equal to VCC minus IC RC plus RE. So VC is 0, so your IC will be VCC upon RC plus RE. VCC is 15, RC plus I is 1 kilo ohm, 1000 ohm, that is 15 milliamps. So this is 15 milliamps. IC saturation. What is cutoff point, operating point now? Option, either option A or either option C. अब निकालो Q point. So what is IB? Beta value is given. How much? 100.
The distance is
Yeah, answer is A. 2 volt and 13 milliampere, almost 13 milliampere. So minus 15 plus IB into RB 10 raised to power 5 plus 0.7 and then beta plus 1, I'll take 100 only, beta RE into 100, okay, into IB equals to 0. So IB will be 15 minus 0.7 divided by 10 raised to power 4 plus 10 raised to power 5. So I almost, this is 10 raised to power 5 only, so this is how much? 14.3 and this is 10 raised to power 5 only. Okay, so कितना आ जाएगा? 143 microampere. नहीं, and beta is 100, तो कितना माइक्रोएम्पियर हो जाएगा? 14.3 microampere. 13, so if you divide, if you do accurately, then this is 101. Okay.
सर आपने वो नीचे जो डिवाइड किया वो क्या है 10 to the power 4 plus 10 to the 5
हाँ, वो कितना आएगा? और
110 के
110 की, अच्छा 110 के, this will have 10 to the power 3. Then how much will come?
1.3
113 milliamps. So 100 multiplied to 13 milliampere. Okay. ठीक. So VC कितना आएगा? VC 15 minus IC is 13, RC plus RC 1 kilo ohm is milliampere. So this will come 2 volt. So point will be here 2 volt and 13 milliamp, close to the saturation region. क्वेश्चन 12.
5.74
तो क्वेश्चन 12 में क्या हो जाएगा? दिस इज करंट मिरर सर्किट. You can write minus VCC plus 5 kilo ohm IR plus 0.7 equals to 0. So IR will become, VCC कितना दे रखा है? What is the value of VCC? 30 minus 0.7, 5 kilo ohm, 5.86 milliamps. So I naught equals to beta upon beta plus 2 into IR. Approximately कितना आएगा? ओके, स्टॉप. बाकी के सब पे चेक करो, सेम आ रहा है. यस, आईसी पूछा है क्वेश्चन में. बट आईसी I naught is basically IC. I naught is IC. Alright. Okay. So we'll stop here.